Hello everyone, I hope you are doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is solve the Sudoku, and it is a hard level problem. So I believe like the problem itself is not very hard, it's just that it has some implementation details. Other than that, if you have seen my yesterday's videos, it is exactly similar to it. We are going to follow the exact same steps, only the implementation or how we are going to store the information will be a bit different, and that is the only hard part about this particular problem, right? The rest of the things are very easy and straightforward. If you watched my yesterday's problem of the day video, which I believe a lot of people did, then it will be very helpful to you. If you have not watched it, I would highly recommend you to watch it first, because I've discussed very basic steps there, and I'm going to repeat it again, but it would be just better if you would understand those steps with the help of a smaller example, right? So today also we are going to follow the exact same steps and change our implementation. So the problem is very straightforward. It says that we have been given a Sudoku grid, right? And we have to fill the squares in such a way such that it satisfies all the conditions of a normal Sudoku. These are the three conditions that have been given to us, and they're saying that the input that has been given to us only has one unique solution, so we don't have to worry about any other thing, right? And the input grid will be filled with numbers like these, and all the places you see here blank, right, they will be filled with zeros, right? So let us take these three conditions, because it will be very helpful to us, and we will see how we are going to try to satisfy all of these conditions. So let me just keep it aside for now. So before discussing the conditions, let us discuss what we generally do in recursion and how do we set up base case and all the other things. First of all, this problem is related purely to recursion and backtracking, right? I would say that backtracking is nothing different. It's just simple recursion. If you get the idea of recursion, then backtracking is not a difficult task. It is very similar to yesterday's problem. So the very first thing that we need in recursion is base case, right? So there are two requirements for recursion. Let me just make the font smaller. So there are two requirements for recursion, right? So the first one is base case and the transition from one state to next state, right? These are the only two things that you need. So let us first discuss what will be the base case for this particular problem. So I would say that whenever you have crossed the whole grid, that means you have found your answer, right? So whenever you have crossed the whole grid, you have found your answer. Why is this true? Because if you were not able to find the answer at any particular point, then you would be directly returning from there, right? So this condition should always satisfy, because if there is at least one such point for which the answer does not exist in the grid, then you will never be able to move forward, right? This is our idea. Now let us discuss the next point. What will be the transition, right? So if you are at a cell I comma j, right? If you are at a cell I comma j in a grid, then you would try to move to I j plus 1. That means you are trying to remain in the same row, but you are advancing one column, right? Now if j becomes 9, that means you have moved out of the grid. Then in that particular case, I will become I plus 1 and j will become 0, right? So this is how you would make the transition. These are the only two things that you need. This is the first point and this is the second point. So the transition is, let's say, let me just also draw a grid, a simple grid. So let's say this is our small grid, and this is I1 J1, this is I1 J2, and this is I3 J3. Let's say this is I2 J1, right? So if you are at this particular row, you're moving one step forward by incrementing j each time, right? Now at this particular step, you will go to j is equals to 4, which is not a valid case because it is out of the grid. I have taken 9 here because the overall grid will be of 9 columns. But since I have already drawn 3 columns here, as soon as my j becomes 4, I would move on to the next row, right? So I would do I is equals to I plus 1 and j is equals to 0. In this case, since j was starting from 1, you could have taken j is equals to 1. But if you are taking 0 based indexing, then you can write j is equals to 0. Right? So these are the two things that you need to have. So before moving forward, I would just like to tell you one more way of doing the same thing. I have implemented it during this particular method, but you can also do it this way. Let's say this is I1 J1. You can also try to move to the row below it. So it will be I2 J1 and then I3 J1 and then here it will be I1 J2. Right? So you can try to move here, and whenever you see you are out of the rows, then you can move on to the next column. Right? Both of the ways are equally valid. You just need to traverse the whole grid. You can do it either way you want, but in this particular problem, I have implemented it using this particular method. Right? So now we have discussed how do we move from one state to other. Now before moving or before making the transition, we need to fill this particular state with some values. Right? How do we do it? So let's say at a particular position it was 0 present. Right? Now let me just draw the whole grid first, then it will be much easier to understand. So let's say this is one cell. Right, I believe this is a 9 into 9 grid, and you will see, let me just mark these subgrids as separate. So this is the first subgrid. Right, this is the second subgrid. Like these subgrids will be present. Right, so let me just draw it completely. So let us see what were the rules. So it says that each of the 1 to 9 digits must occur exactly once in each row. So let's say this is first row, this is first row, this is second row, this is third row, this is fourth row, fifth, sixth, seventh, 8 and 9. Right. So 1 should exactly occur once in this row. Similarly for 2, 3, 4, 5, 6, 7, 8 and up to 9. Right. Now each of the digits must occur exactly once. So I need to maintain some kind of a data structure to save this information that I have already taken some digit x in this particular row and I cannot take it again. Right. For example, if there was a 0 at this particular point, right, you would want to place some number except 0 here. Right. So what you would do, you would try going from 1 to 9. You would try checking all the digits from 1 to 9. But it is saying that for each row you can take all the digits exactly once. If you want to take some digit x among these 1 to 9, you will have to check whether it has been taken already or not. If it has been taken already, then you cannot take it again. Right. Similarly, the second point is each of the 1 to 9 digits must occur exactly once in each column. Right. Similarly, if you're checking for this particular row, you will have to check for this particular column as well. Right. That this particular number x that you are trying to take should not occur in this particular column. Right. So how do we store this information for rows and columns? What you can do is you can simply maintain a double dimensional vector. Let's say this is for rows. So let's say this is a double dimensional vector. Similarly for columns, you can maintain a double dimensional vector. Right. Now let's say you are talking about row 1 and 1, 2, 3, 4 and 5. You're talking about column 5. Right. So you can check if rows of 1 comma x and columns of 5 comma x is not taken. Right. So both of them should not be taken, both of them should be 0 or both of them should be not visited. Right. You can say it anywhere, but both of them should be together, not taken. Remember, even if one of them is taken, you cannot take x at this particular position. Right. Now the third point was each of the digits 1 to 9 must occur exactly once in each of the 3 into 3 subgrids. Right. So I have drawn these subgrids here, but now we will see what is the significance of these subgrids. Right. So they are saying that each of the digits must occur exactly once in those subgrids. So for example, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is how you will see that each of the numbers will occur exactly once in the subgrid, and even if I write 8 here, it is not valid because 8 is repeating twice in this particular subgrid of size 3 into 3. Right. Now let me just remove all of this, and now let us try to number these subgrids. Let us do something to label these subgrids. So let's say this is subgrid 1, this is subgrid 2, this is subgrid 3, 4, 5, 6, 7, 8, 9. So you will realize that there were 9 rows, there were 9 columns, and now there are 9 subgrids. Right. So we can use the same method to find whether the number x has been taken in this current subgrid or not. But it is not as straightforward as rows and columns this time. Right. You will have to do something about it. So this is the first subgrid, this is the second subgrid, this is the third subgrid. I am able to visualize it with the help of drawing, right? But how will I make the computer visualize it, right? So what you can do is you can consider this as a 3 into 3 array, right? So in this array you will see this is the first subgrid, second subgrid, third, fourth, fifth, sixth, 7, 8, 9, right? Now I know that this is the grids that I have. So how do I convert a cell position I comma j, which can be from the range 1 to 9, to one of these grids, right? You can do it easily by dividing both I and j by 3. So if I divide I by 3 and j by 3, you will see that if the value of I is from 0 to 2, it will lie in this first row. If the value of I is from 3 to 5, it will lie in this second row. And if the value of I is from 6 to 8, it will lie in this particular third row, right? So I am talking all about zero based indexing. Similarly, I can divide the value of j by 3, so it will form column 1, column 2 and column 3, right? Now that I have converted this big grid into a smaller grid of size 3 to 3, so what have I achieved by converting the bigger grid into a smaller grid? Now you will see all the cells that were present in this whole subgrid will be represented by only one cell here, right? And that is R1C1. Similarly, all the cells that were present in the second subgrid will be represented by this one single cell here, that is R2C2. That means I will be able to identify which are all the cells that are present in the same subgrid. For example, if I1 and J1 and I2 and J2 both belong to R2C2, that means they are in the same subgrid. Now that I have found the relationship between the cells and their subgrids, now I can use this information to store whether a number x has been taken in a particular subgrid or not. Now there are actually two ways of doing it. Either you can maintain some kind of a map where you will store that in cell R1C1 your x is taken or not, in cell R2C2 your x is taken or not. Similarly, for all the things you can store it like this. Now you can store this whole information in a map. Let's say you have a map like this, right? The first key can be a pair and the second key can be a vector of boolean of size, let's say 9, right? So you will be able to identify which of the 9 values has been taken in R1C1, similarly for R2C2. So you can go ahead with this particular method, but the way I implemented it was even more optimized so that you don't have to use a map. So I'm going to discuss a very popular idea, and that is used in many programming languages. So you will realize that all of these double dimensional matrices or any multi-dimensional vector or array is not actually stored like this in the memory. It is always stored in a single dimension array, and they use some mapping function to identify that R1C1 will be present at index y, and then R1C2 will be present at index y plus 1, and so on, right? So all of these information of even double dimensional or multi-dimensional vectors is essentially stored in a single dimension array or vector in memory, right? So we are going to discuss a popular method known as row major. It is used in many programming languages inbuilt, right? So we are going to use row major to optimize storing this particular information, right? So what I can do is, let's say all the rows are from 0, 1, 2 and all the columns are from 0, 1, 2. So I'm talking about this smaller grid. So you will see there are 9 values here. So let me just create a single dimension array of size 9. Right. Now this is index 0, this is index 1, this is index 2, this is index 3, 4, 5, 6, 7, 8. Now I can do the same thing here. I can represent it with index 1, 2, 3, 4, 5, 6, 7, 8. You will see there are 9 values here and there are 9 indexes here. So I can store each of those 9 values here in those 9 indexes. But the problem is, how do I convert this particular I and j into some index from this particular array, right? So first of all, let me just tell you that the right formula, and that is, let's say you are at index I comma j. Its correct index in a one-dimensional array will be I into 3 plus j. This is called row major, representation of a multi-dimensional array into a single dimensional array. So what I am doing is, I am writing all the rows first one by one. right? So 0, 1, 2 are as it is. Whenever I move on to the next column here, you will see I'm starting with the next multiple of 3, right? So that is why whenever I take a new column, I will multiply it with 3 because there are 3 number of columns. If there were, let's say, x number of columns, I would have multiplied it with x. This represents that I have moved on to the next one, right? Now similarly, when I get 3, I can write 4 and 5 after it, right? 3, 4 and 5. Now whenever I move on to the next row, you will see it is the next multiple of 3. So I write it as 6 here. So basically I'm trying to write all the rows line by line. And since there are 3 values in each row, I'm multiplying this row value with 3. It should start from a multiple of 3. So you don't actually need to understand this part of row measure. You can just directly write I into 3 plus j. Right. So this will be the final formula. Now let us recall what we have discussed till now. So we have discussed what is the base case. We have discussed how to make the transition, right? How do we make the transition? First of all, we need to understand how do we move from one cell to another. And before moving on to the next cell, we understood that how do we assign the values. So if that particular value x is not present in the current row, if that particular value x is not present in the current column, and if that particular value x is not present in the current subgrid, then only I can take that particular value x, right? So rows and columns were very easy to understand. But how did we implement subgrid? First of all, we wanted to associate all of these cells with one subgrid, right? So that is why I converted this whole 9 into 9 grid into a smaller 3 into 3 grid. Now with the help of this 3 into 3 grid, whenever I get two cells, I will be able to tell whether both of the cells are part of the same subgrid or not. Now I needed to save this information somewhere. So I converted this double dimensional grid into a single dimensional array with the help of row measure representation. Right. So I will be able to tell whether any element x has been taken in the current subgrid or not. So if I have not taken that particular element till now, and then call my recursive function on the next cell. So this was all about this problem, and let us have a look at the code, and then all of these things will be much clear to you. So you see, this is my find function, which is actually going to do the conversion for me. We'll have a look at it later. And at the end, I have my print grid function. This is also a very simple function, just traversing through all the values and printing all the values with the help of a space, right? Now you will see I've created 3 double dimensional vectors. The first one is rows, the second one is column, and the third one is subgrid. So I've taken the size to be 10 on all the grids because I wanted to use one based indexing for all the values of the grid from 1 to 9. That is why I've taken 10. So now you can see this, the first one is for the rows, the second one is for the columns, and the third one is for the subgrids, right? All of these things we have already discussed, and now let us have a look at this particular part. So this is the part where I'm initializing the whole rows, columns, and the subgrids part. So in this particular part, I'm just saying that in the ith row, this grid of ij is present, right? So I am marking it as true or I am marking it as positive. In the column j, this grid I of j is present, right? And in the subgrid find I of j, this grid I and j is present, right? So this find function will help me to actually find the subgrid of which this I and j are a part of, right? So let us also see what is in this find function. So first of all, I have already told you I will convert the whole index x and y into a smaller subgrid. So I am dividing both of them by 3, and I will find the final index in a single dimensional vector of this x and y with the help of this formula x into 3 plus 5. This is nothing but just a row major formula, and this is also implemented internally in many languages whenever you are using a multi-dimensional vector or array, right? So we have just implemented it here explicitly. This is not a very new idea. This is very basic thing that you will generally study in computer science classes, right? Now, since I have marked all of these things, rows, columns, and subgrids, now that means I have already marked the initial state of the grid. Now at the end, I can just call my helper function at 0, 0. So it is returning something, right? So in this whole function, we have to return a Boolean value whether a solution is possible or not. So I'm just calling my helper function at 0, 0 and returning whatever this function returns, right? In my helper function, I see if the row number is 9. That means I have crossed all the rows, right? Because the rows were from 0 to 8. If the row number is 9, that means I've crossed all the rows and I've completed the grid. So this will be the base condition and I can return true from here. That means I have found a valid solution. Now my next I will remain as it is, right? Because the I is not going to change. And my next j is going to get incremented by 1 because I'm moving on to the next column. If my next j becomes equal to 9, Then I'll increment my next I and I'll update my next I as 0. So basically I'm just trying to calculate what is the next cell I will go to. So the next cell will be next I comma next I. Now if not grid of I, that means grid of I has a value equals to 0, right? That means I need to put some value here. So what I do, I just traverse through all the values 1 to less than 10, that means from 1 to 9. So I am trying to choose this particular value. So if this particular value choose is not present in the ith row, if this particular value choose is not present in the jth column, and if this particular value choose is not present in the current subgrid, in that particular case, I'll mark my grid of ij as choose. I'll update all of these things. All of them were earlier 0, 0, 0. I'm updating them with 1, 1, 1, right? And I'm calling my helper function on next I and next j. Now you will see I'm capturing some value from it. So this will return a true or false value. So after taking this value, if a solution is possible from the remaining values, then this helper function will return true, otherwise it will return false. If this function returns true, then I will just directly return from here returning true as well, right? Because if helper returns true, that means I don't have to explore any other values, right? If it returns false, that means a valid solution does not exist with this particular value of choose for the current cell. That means I have to mark all of them as false again. I'm resetting the value of grid of ij, I'm resetting the value of rows ij, and similarly for all the other columns and subgrids. Why am I doing this? So that I can mark all of them as unvisited and I can try some other value, right? Now if this grid of ij already had some value, then what I can do is I can just return helper of next I next j, right? Because I don't need to change any value here. Now at the end, if there was not even a single position where it returned 1 or where it returned true, that means the answer is not possible for this particular cell, and that is why I have to return 0 here, right? Now this print grid function will be called automatically by the driver function. We don't have to call it explicitly. We just have to return whether a state was possible or not. So this was all about today's problem of the day. Let me just quickly submit this and show you that this particular code works. You see it passes all the test cases and the solution is absolutely correct. And you see that it is very much similar to yesterday's problem. It has a base case, it has a transition, and all the other things are the same. The only difference is in the implementation, you see there was only one value here which we were changing and resetting. Now there are 3 or more values. So this just increases the writing complexity or the implementation complexity of the problem. But the key idea is always the same, right? So that is it for today's video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and to be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost and you can always subscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.